Okay, welcome everyone to the Manchester Java community. Today we're joined by José. So welcome, José.
Thank you.
First of all, just like to say a couple of thank yous to our sponsors. So I'd like to thank RepWorks. They cover our meetup fees for the Java community. So we really appreciate that. And probably just a couple of shout outs to a couple of events that are happening coming up. So one is the London Java Community Unconference. I'll drop a link to that in the chat shortly. That's a nice kind of informal event where you've got some really cool kind of Java people from the community across the world essentially joining. And I think I might leave it to José to talk about the other one that I was going to mention, which is JChateau and JAlba are doing a bit of a collaborative Unconference as well. But I'll leave that to you. So yeah, I mean, ultimately, over to you, José. I'll let you introduce yourself properly.
Okay, thank you. Well, first of all, thank you for your invitation. I'm very glad we can set up this meeting. We were just having a quick conversation about how great it was to have in-person meetings. Okay, hopefully it will happen again in the future. So we're going to talk about those three topics, which are topics that are quite hot at the moment because Java 17 has been just released in September. And those three are being released partly with Java 17 and with the previous versions of Java we had in the past few years. So just a very quick introduction of who I am. So my name is José. Here I just put some links on the content I share on the internet. There is a lot, and I try to organize things in the best way possible. It may not be super great, but still. Yes, as you just mentioned, Nick, we are also organizing. We joined our efforts with the JAlba Unconference organized by Maurice Naftalin from Edinburgh. And we created a joint event, online event called JOLD, which stands for the Old Alliance, JChateau and JAlba. And it will take place next week, starting Wednesday with the kickoff, which will not take more than 1 hour. And after 2 afternoon sessions on Thursday and Friday. The event is free, of course, and online only. That's the 3rd edition of this event. So we are, I think, quite okay with all the technical aspects of the Unconference. And we already have quite a lot of people who registered, but if you feel like joining, you're of course more than welcome. If you don't know what an unconference is, because it's not a conference, it's an unconference. And if you don't know what an unconference is, you may give it a try, or at least try to know that. If you are here, it's because you like technology and you like jugs and you like sharing and these kind of things. Unconferences are exactly about that, and they are a really great event. If you never participate in an unconference, you should really give it a try. And the second thing I would like to mention is also, along with the release of Java 17, I work for Oracle. Yes, I forgot to mention that, as a Java developer advocate after working for university as an assistant professor in Paris for 25 years. That's quite a lot of time. And we just released Java 17, and along with it, we opened for business this website, dev.java, which is both a website with documentations and things about events, about communities, Java champion, jugs, etc. Kind of a one-stop place where you can find many information about Java, including, of course, documentation. And that's the welcome page of dev.java that I took just a few weeks ago. It may have changed in the meantime. All right. So unless you lived in a cave for the past few weeks, you're probably aware that Java 17 has just been released. And the question is why should you be should you be interested in Java 17? Well, it's because of this kind of statistics, right? If you try to understand the market share of the different versions of Java currently, about between 2/3 and 3/4 of it is Java 8, and the rest is Java 11. Now, why is that? Because I think that there is a very simple answer, is that both Java 8 and Java 11 are the current so-called LTS, long-term support versions of the JDK, and Java 17 is also an LTS release. All the releases between 11 and 17 were just, I would say, normal distributions, and 11 and 17 are going to be are LTS releases. So maybe in a few, the world will look like this one, with a fair amount of people who have moved to 17. I guess more and more people will move to 11, and more and more people will leave Java 8. Java 8 has been released almost 8 years ago, so it's already an old version, an old revision of Java, I would say. There are many very interesting things in it, but you need to understand that now it's almost legacy, right? Even if you're on Java 8. And this is exactly the moment where I really regret that we are not in the same room, because I would ask the question, are there people in the room currently running their application on versions older than 8, 7 and before? And if it's the case, you need to consider that Java 7 is 10 years old, 2011. And yes, this is super legacy code. You should really do something to move from a more recent version. And along with the release of Java 17, two things have been announced. The first one is that instead of having one LTS version every 3 years, we should be moving to one LTS version every 2 years, meaning that in a far away future, the future may look like this one, with the Java 21 version being the next LTS release. Instead of Java 23, it will be Java 21. I think it's a good news for people like us who are writing code, who are developers, because it means that all the new and shiny things I'm going to show you, some of them are still preview features or upcoming features, not even preview. You will be able to use them and to play with them and to leverage them to write better applications in a future that is closer than what you think. And I can see some kind of a poll that just popped up on my window. Let me try to grab it so that I can see it better. Where are you? No. Yeah, here. Which Java version are you using? 8, 11, 17. You should have put something before 8, because, well, maybe some people are still using version before 8. All right, okay. And so the first thing that has been announced is this LTS release, which will hopefully be Java 21. The next thing is that the license that you can use to run your Java application is going to change. Well, changed for 17 and will be kept for 21. Basically, I would just say, put it in a very short statement. That is something that was that you needed to pay before is now free. That is the Oracle JDK, which is the Oracle distribution of Java 17. It can be used for free in production instead of having to pay for the previous context of Java 11. And I'm just mentioning this talk that has been released on YouTube just a few days ago, where it's quite a short talk. It's I think 20 or 30 minutes, and the first 10 minutes is really on this exact topic. That is this new license that allows you to use Java 17, the Oracle JDK 17 for free in production on your application. Now, I'm not going to talk more about this, because licenses and this kind of thing is really a lawyer thing. I'm not a lawyer. I prefer to define myself as a developer, and I don't want to say any wrong things. So I prefer to leave the statement and the talks to the people who are talking in this video. All right. The next thing I just would like to mention and to show you is the amount of new stuff that has been released between 8 and 17. having a faster release cadence, one version of Java every 6 months and one LTS version every 2 years, does not mean that the amount of new features per year is changing. It's not decreasing, certainly not. I would say it's probably slightly increasing, but this chart is just here to show you that, in fact, in the 4 years between 8 and 11, you have an amount of feature that is roughly constant if you divide that per year, which is a great thing. It means that the Java is still on its way to innovation, to embrace new functionalities, new features in the language, in the JVM, in the tooling, in all aspects of everything. Here is a slide with, I would say, most of the new features of things that you can expect if you move from 8 to 17. Of course, we are not going to deep dive into each of them because it would need much more than 1 hour to do that. But there are things that you are going to get for free, right? Just upgrading from 8 to 11 or 11 to 17 or 8 to 17 give you elements that will make your application faster without touching your code, without even recompiling. Okay, I would just like to mention one point, which is in the language, that the last line of the language, which is compact string. Compact strings have been introduced in Java 9. And what is it? It's just that if your application is using string of characters, and I would say most applications are using string of characters, you need to know that the string of characters is now wrapping an array of bytes instead of an array of chars, which was the case between 1 and 8. Okay. What difference does it make? Well, if your application is handling only Latin 1 characters, that is characters that can be encoded on 7 or 8 bits, well, you are going to save about 50% of memory on the storing of your string of characters. So you'll get much better performances for the garbage collector. The pressure on the garbage collector, which will be much lower. And you will consume less memory. And you don't have to recompile your code to have that because it's in the JDK. So if you just move from one JDK 8 to JDK 11 or 17, you will get that for free, right? Now, if you recompile your code, you will get in-defined concatenation of string of characters, meaning that you don't have to use string builders anymore, or string buffers or whatever, this kind of ugly pattern to write string concatenation. You just write S1 plus S2, and that's it. And the compiled code, the bytecode, changes in Java 9. There's now a call to invoke dynamic, and the concatenation is taken into account, is implemented by the JVM instead of being encoded in a bytecode, and it's faster. To do that, to leverage this point, to benefit from this, you need to recompile your code, of course, because if you have a Java 7 compiled code, you will have the creation of the string builder and this kind of thing. So you don't want that anymore. You need to get rid of that. So you need to recompile your code. And once you've done that, you will benefit from the improvement of the JVM version 9, 10, etc., all the way up to 17. So those are really things that you get for free, I would say, without having to touch your code, without having to touch anything, which is really great. So yes, do that. By all means, do it. I would like to we are not going to spend a lot of time in slides, okay? I would like to give you 2 words of warning if you want to move from 8 or 11 to 17, and after that, of course, which are things that are going to be deprecated in your code, right? And the first thing is the constructors of wrapper classes. Here I'm showing you the integer class, but it's the same for the double class, the float class, long class, etc. Okay, the public constructors that take the primitive type value of this wrapper class corresponding to this wrapper class have been deprecated for removal since Java 9, and they are going to be removed in the future. That's for sure, because this is something that is mandatory for the Valhalla project and what is currently called inline classes. So if you have calls to these constructors, if you see calls to these constructors in your code, you can just replace that by value of. I think this is something you can almost do with a search and replace. So it's very basic refactoring, super simple. And it is now the preferred way of creating integer values, integer objects, not values. And the same for the wrapper classes. So you need to get rid of this. And the second thing that you need to be aware of is that finalize, it's still a project, but finalize may be deprecated for removal in the close future. The JEP is a candidate JEP, meaning that it has been accepted as a JEP and not accepted as being integrated in the JDK 18 coming in March. But there is a high pressure that this will be the case. Most of the time, when you have code in your finalized method, that is an override of the finalized method of the object class, it is a bug in itself, okay, most of the time. There are many reasons for that. So just don't do it, don't do it. I just would like to cite a tweet by Mark Reynolds, who told that, yes, he's been looking forward to deprecation of finalize for removal for a very long time. So this will probably come in the future, sooner than we think. Okay, and this is what I wanted to tell you before talking about records. And you know what? I think I'm going to switch to the IDE. What do you think? Don't you prefer watching code instead of watching slides? So I need to switch to presentation mode, which is the case. And now I need to understand how I can okay, I'm going to end this. This will show. Yeah, now I don't have any screen share anymore. So let me share. Where can I get that? Sorry. Screen sharing. And now you should see.
Yep, see that.
My IDE. Yeah, that's the case? Yep. Great. So that's a record. I just would like to start with records. Records are a super simple concept to understand. It's just a class, in fact. A record is a class, okay? It's a class, so you know what a class is, of course. There are several things that makes records special. The first one is the fact that when you declare a record, you also declare this piece of code with it. It looks like a constructor, but it's not a constructor. It's the state that this record, this range record, can carry. Okay, here we have a range record that defines what are called components. Begin and end are components of this record, and it's describes the state that this record can carry. And there is a very special rule with records, is that this record cannot carry any other state than this one. And to enforce that, it's not allowed to have a private instance field in a record. The compiler will tell you, no, I don't want them. Okay, so you can't have them. All right. A record class already extends a special class named record, which is a class from the JDK. So your record cannot extend anything else than that, even if I try to extend object, for instance. Okay, this is not going to work because record already extends this record class. And this class that encodes a record is final, so you cannot extend it. All right, so a record cannot extend anything, cannot be extended, and it cannot have instance fields. So the components of a record fully describe the state of this record. Now, what do you get with this record? You get a constructor that takes the component as parameters. And if I run this code, you're going to see that this constructor is working properly, which is expected. Okay. You also get a toString method, and this is the result of the calling of this toString method. And what you also get, let me do this, is accessors. Here I have an accessor called begin and an accessor called end. And I also get an equal method and an hashcode method generated by the compiler for me. Okay, so that record, it may look like a Java bean, but it's not a Java bean. It's different, but it's really something that carries a state and that has all the methods you would expect from such an object. You may be thinking that it looks like, sorry, and it's this guy that I want to show you. You may be thinking that this looks like the kind of thing that Lombok is doing for you, and it does, but it does more than that. If you check the bytecode of a record class, you will see that the equals to string and hashcode methods are implemented using invoke dynamic, meaning that the real implementation of these methods is in fact provided by the JVM. So currently we have a current implementation of everything of the record in the JDK 17, but these implementations can be improved and optimized in the upcoming versions of the JDK. And you will get those optimization for free without having to recompile your code, because the real code is in the JVM and not in the bytecode. And they are also a little more than that, and we're going to see that in a minute. If I try to create a range, let me do that. I'm going to create a range, we call it range 2, new range from 10 to 0. I would probably would like to put some kind of validation rules to make sure that I cannot create a range with a begin that is greater than an end. Okay, you can do that by just redefining the constructor of this record. Okay, I need to say that begin copies begin and that end copies end. All right. If I don't do that, you see, if I don't do that, then I have a compiler error at this level telling me that this is not initialized. Why? Because those fields are final in a class. I can see that there's a question. Would you recommend replacing Lombok or auto-value generated classes with records? Understood, records cannot create a class hierarchy due to being final, right? I would recommend that, and I'm going to show you why in a minute. Okay. So far, you haven't seen the biggest impact on records on your application. So, and here in this constructor, I can say that if begin is greater than end, which is something I want to avoid, then I'm going to throw a new illegal argument exception. Begin should be smaller than end. And that's it. And now if I try to run this code, of course, I will get this exception because this is how Java is working. Great, that's the exception I'm getting. I just would like to remove this guy so that we can see the code better. This constructor is called the canonical constructor of a record. And whatever you do, this canonical constructor is always called by any constructor you can create in a record. You see, if I create a record, a constructor without any argument, and I would say that this is, for instance, the empty range, I need to call this canonical constructor. All right. I could also create another constructor only with the end. Well, this constructor, if I don't call the canonical constructor, I get a compiler error telling me that I need to call it. So I'm going to call it, for instance, in that way. And because this canonical constructor always has to do the same thing, that is, take the components of the record as parameters and copy these components in the private fields of the record, I can get rid of it and write it in that way. That is, remove the purely technical stuff that is always the same. And you can see that my code is still compiling. And this is called the compact constructor. The compact constructor is, in fact, a simplified way to write the canonical constructor. So now what I see is that a record, this range record, is a range defined on these two integers and with this validation rule in the middle here, which is really great. I'm going to get rid of this. Get rid of that because I don't need them. It should still be working, hopefully. Yeah, great. And what I would just like to show you is that you can implement interfaces with a record. Let me implement iterable of integer, for instance, because I can iterate over a range. I'm going to ask my IDE to implement the method for me, the iterator method. Great. Now I'm going to return a new iterator of integer. I'm going to put an index in this iterator, and this index will start at begin. Okay, as next is true as long as the index is lesser than end. Because I have this validation rule, I can do that. And next will be just index plus plus. I can get rid of a few. Great. And now with this implementation of the iterator method, I can just iterate over a record, index over range, because this for each syntax may take any iterable object here. And iterate over range. Okay, and this is working as expected. So that's the gist for a record. It's a very simple concept. A record is built on components, all right? And the components are declared when you declare a record. And basically, you can just create record for free. You can put that everywhere in your code if you wish. It works just super well. Now, I told you that the canonical constructors, the canonical constructor of a record is always called when you're trying to create a record. And there is, of course, a corner case, which is serialization. You know that when you serialize an object and you recreate an object from its serialized form, the problem is that no constructor is called in the process, all right? If I take here, I created a range class, which is this class, all right? And this range class, implement serializable, is just the class that mimics the behavior of the corresponding record, of the record we just wrote, right? With a toString method. I did not create the accessors, but basically this is what you have along with other things. Here, I have a bug in my application. I forgot to add the validation rule. But if I run my code, now I'm creating a range class and I'm serializing. This range object is corrupted, okay? I did that on purpose. And I'm just writing the serialized version of this object in this file, which is on my file system, okay? And now what I want to do is deserialize the content of this file and print out the result. But in the meantime, I had a bug report telling me, oh, your range objects are missing the validation rule. And I, of course, fixed my bug. So now the situation is the following. I have a correct range class, which is a bean, with a correct validation rule. But I still have, in my application, a serialized version of a range of this class that has been created before the validation rule was added to the constructor. What is happening if I try to deserialize this code? Well, because serialization is using a list of acts and not calling any kind of constructor, the problem is that nothing happened. And despite the fact that my validation rule has been added in the constructor, and that this class has only one constructor, okay, which is this one. This constructor is not called by the deserialization process, and I have a corrupted range object now in my application. This is a major security breach and one of the many problems raised by serialization. Now, what I told you is that range records are always constructed using their canonical constructors. So I also have a range record, which is here. Okay, the same range record as the one I just showed you previously. The compact constructor is commented out, so the validation rule is not in that record yet. What we're going to do is just create a corrupted record, store it in another file. I'm going to comment this out for the moment. Run this code to create the file with the serialized corrupted record. Okay. And now I have my bug report telling me, oh, but you forgot to put your validation rule here. So let me put this validation rule again. Okay. Comment this code. And now I am going to try to read the content of this file, which is corrupted, in this new record and see what is happening. Now you can see that my corrupted record could not be deserialized. Why? Because the deserialization process calls the canonical constructor in the case of records, which is not the case in the case of class. So that's a security breach that is now closed thanks to the use of records. And this is specific to records. And I think that if you're using serialization and if you have validation rules on your serialized object, this is really something you should consider using in your application. Okay. Now, if you are using, if you have legacy object in your application, I'm going to show you something I just created. So here, I have a range legacy object. Okay, that is just a plain bean. We could say that with a validator there that is called. I just put the validation rule in its own class to be called from somewhere else. Okay, and I'm going to reproduce the same kind of context where this range legacy class doesn't have its validation rule, and we're going to play with it. So basically, this class is the same as the previous one. Call this code. So this is, I'm going to create an instance of an illegal range legacy stuff, put it in this file. So let me do that. Okay. Where am I? I'm here. Okay, but in fact, what I'm going to do, because I am using this range legacy class in my application, and I cannot really replace it with a record because it's too complex, my application is too big, etc. I can still leverage the record serialization stuff to with this legacy class. For that, I need to use the write replace read resolve mechanism, which is a very old mechanism from serialization, where in fact, instead of recording a range legacy instance in a serialized stream, what I'm putting is a proxy object. Okay, this is only basically 3 lines of code. I don't have to put this system out println. It's just here to show you how it's working. But it's basically 2 lines of code, and this range proxy object is a record that is calling the validator. And by the way, I'm going to comment this out. That is calling the same validator as my legacy object. Okay, so now in my serialized form, I have a record instead of having my legacy object. So let me run this code. Serialization. Okay, I'm going to run you. So in range legacy, instead of having an instance of range legacy, I have an instance of my record. All right. And how can I recreate my object from this serialized form? In my range legacy record, I need to tell the system, oh, by the way, when you are deserializing me, you need to run this stuff after that, which is encoded in the write replace method. So this is why this mechanism is called read, resolve, and write, replace. In the object that is deserialized, you need to have this write, replace. And now if I run this code, so if I try to deserialize that, you should be here. What is going to be deserialized is really my record. Okay, I am creating the real object. My record is being deserialized and my range legacy object is being recreated from this record. And now if so this object serialized is corrupted. So what I'm going to do is go back to my record and activate the validation rule in that. And of course, because this compact constructor is called by the deserialization process, if I run this code again, now I will have an exception in the recreation of the record. So even if you cannot really replace all your legacy Java beans and stuff or data transport objects with records, you can still use this serialization protection that records bring you using this write, resolve, write, replace, read, resolve mechanism from the serialization framework. All right. That was for record and legacy stuff. The last thing I would like to show you are the thing about seal classes and pattern matching. So what are really seal classes? Okay, seal classes, I'm going to remove this. Well, yeah, to re-put it in just a minute. A seal class, first seal class, I'm going to talk about seal classes and I'm going to show you how it works on an interface. But really, you can do that on any kind of type. In fact, it's really called seal types because you can seal classes, abstract classes, or interfaces. What is a sealed interface? It's just that sealed interface. You just add this keyword in front of the interface. And what you need to do when you do that is that you need to tell this interface, oh, there are only several classes that are allowed to implement this interface. For instance, the square class and the rectangle class. Okay, and now it's not working because I need, of course, to tell that this implements shape. Okay. And the same for rectangle. And now it should be okay. What is wrong with you? Must contain. Oh, I'm sure that you are also implementing shape. So let me get rid of this. Okay, and that's it. When you declare the seal type, you need to tell the compiler what are the types that are allowed to extend this type. Now there are restrictions to the type that extend this sealed type. The first restriction is that these types, square and rectangle, are records here, so they are classes, must live either in the same package if you are not using Java modules, and if you have a modular application, they must live in the same module. Okay. The idea is that the compiler needs to see all the hierarchy of types that you are creating, all the seal hierarchy of types that you are creating at the same moment. You cannot say, oh, I'm going to compile this interface and I'm going to show you the different types that are permitted to implement this interface later on. This is not possible. So that's the first restriction. There are other restrictions. The classes here that implement this interface have to be either final. So if I put here a regular class, I'm going to get rid of this. It's not going to compile because the class is not final. If I add the final keyword here, then it's going to be okay. Because the record is an implicitly final class, it's working here. Okay. They can also be non-sealed. I'm going to do it with a rectangle, for instance. Okay, so if it's a class, I could say that, oh, but this class is non-sealed. So it's an open point that can be extended in this hierarchy. Okay, and it can also be a sealed class itself. If the class is sealed, then it needs a permits clause with the types that are allowed to extend this class, which is not the case here. So that's it. So the idea is that it's really nice because it means that you can create completely closed hierarchy of types. And in this closed hierarchy of types, you can also create extension points where people can go further if you so wish, if this is what you want to do. Now, what is it good for? What can you do with this? Okay, and this is where the things are getting interesting, I think. So suppose that this interface is in fact a business interface that you have in some kind of complex business module, and you want to add behavior to it. For instance, I want to compute the surface of this interface. Okay, this is what I'm going to do most probably 90% of the time. And of course, the compiler is very nice with me because it tells me, oh, but you have two problems. The first one is that the square class doesn't have this surface method, so I need to add it. And the rectangle class doesn't have it either. Now, this is nice, but it has a cost, okay? And in fact, this cost is something that you can see in the JDK. You may remember the old days before Java 8 was released. And in these times, you didn't have a sort method on the list interface. The sort method was on a factory class called the collections class, and the sort method was itself a factory method that would take a list as a parameter. So instead of having a surface method directly on the type, here, and I'm going to put it there. No, I'm not going to put it there. You will have, yes, it can be static or not, whatever. You would have a surface method here that would take a shape as a parameter. I'm just going to put return 0 for the code to compile. This one. Okay. This is how the sort method was done in the early days before Java 7. Why was it made in that way? Because at that time we didn't have default methods in Java, and having a sort method on the list interface itself would have made mandatory for all the people who wanted to implement this interface to add an implementation of a sort method, which was seen at the time as being too complex. Now with Java 8 and default methods, now there is a sort method on the list interface, which is a default method with a default implementation, which fixes all the problems. But the cost of this is really this one. Adding behavior on this shape interface in a business context, in an object model, means that every time you want to add some behavior on the model object class, you add a method on it. You add a method to this class. Is it a good idea? Well, I think that we all know the result of this way of designing object models and APIs. You end up with a contract or an invoice class with 50 methods and 70 fields. That is super hard to move. That is super hard to refactor. That is super hard to implement because you may have a gazillion validation rules in it, and it makes the writing of your tests absolutely a nightmare. And this is not the kind of situation you want. And when you're doing that, most of the time, you have a process to add methods to this class. And you should wonder, how can I remove methods from this class? And most of the time, the answer is you can't. You can't. So when you have something in which you can add, you have a class and you can add methods to this class, but you don't have any process to remove methods from this class, after 10 years, you have, well, what we all know, legacy applications with horrible classes, thousands of lines, and horrible things in it. So instead of putting this method here, we're going to put it on the outside and say that, yeah, we take a shape as an argument, as a parameter, and we're going to compute the surface of this shape. Now, what is this code? What is this code is going to look like? Well, if my shape is an instance of a square, for instance, I'm going to return shape.edge times shape.edge, shape.edge. Guy, and if shape is an instance of rectangle, I'm going to return shape.height times shape.width. Okay. And of course, here I need to add this return 0, even if I know that because shape is sealed, all the cases have been covered. If I don't put that, the compiler will tell me, oh, but there is a path through this method that doesn't mean any returns, so you need to add this return. Okay, this code will never be executed. I cannot write a unit test that execute that can execute this line of code here. All right. Now, and this is where I really regret that we're not in the same room, but I would see your faces. Tell me, ah, but this is really ugly code. And you're right, this is really ugly code. We can make it a little better with the pattern matching, for instance, of here, I can say that this square is a square. And now I can get rid of the casts here. And by the way, I need this. And the same for rectangle. This is a feature of Java. Okay, it's something that you can do in the starting when the JDK 17, you have it. Okay, it has been added a little earlier, but yeah, that's a feature. It makes your code slightly better. Now, you may be thinking that this is just a syntactic sugar, and indeed it does look like a syntactic sugar, but this is really, in fact, a new concept in the language. This square is in fact what is called a pattern. And what we're doing here is pattern matching. You could read it in this way. This shape variable could have it been declared with square. And if it's the case, it means that its type is really square and that you get a binding, what is called a binding variable, a square variable that you can use wherever it makes sense. For instance, if I add and the square dot edge, dot edge greater than 0, then I can do this. Okay, I cannot put or here; it wouldn't make sense, of course, but I can put an and. Right, and this is a new concept in the language, and this concept we're going to use it in many more places than just instance of. All right. What am I losing when I write things in that way? Well, when I added elements to this shape interface, methods to this shape interface, the compiler would warn me, careful, because you have places where this method hasn't been implemented, okay? But here, if I had a circle, for instance, here, tell me that implements circle, implements shape, okay? Now this code is compiling. And here, I don't get any warning telling me, hey, you have forgotten, you forgot to handle the circle case. And this is very bad because if I have this kind of pattern of code spread out in my application in hundreds of places, I will need to refactor everything and the compiler will not help me in doing that, which is a pity. But it turns out that we can do better. Let me get rid of this for the moment. Go back here. Okay, because this if, which really looks like a switch, all right, if I have more classes that implement shape, this switch will have the structure of a switch. I can write it as a switch on shape. By the way, switch became an expression in another version of the JDK. Okay. And with the introduction of pattern matching for switch, now I can write things in that way. And here, case rectangle. And put the 8 and the width just here and get rid of this. And now, because the switch is aware that shape is a sealed type, you can see that I do not need to add a return 0, whatever, at the end of it. By the way, I only have one return, so it wouldn't make sense. And if I add a circle there and tell you that this circle implements shape, you can see that this switch is telling me, oh, it does not cover all the possible input values. So I really need to add, do it in that way, case, circle, 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 and this is not edge, this is radius. And I'm going to say that pi is equal to 1, so it will simplify my formula. Okay, so you get with this switch using pattern matching, because this is really, it's called switch on type, because what really matters is the type of the selector variable that you have here, but the case constants are now really patterns. All right. And it's a new kind of switch. There is all new bytecode that is generated for that. This switch on types, we do not have it yet. It's still a preview feature in the JDK 17. There will be a second preview feature in the JDK 18. The JEP has been published just a few days ago. If it goes well, it will be a final feature in the JDK 19. There's a question I recently saw code like if foo instance of final bar, does a modifier make any difference in a pattern? That's a good question, by the way. That's a good question. Let me write it in here. If shape instance of square. Can I put the final keyword there? Oh, yes, I can. I absolutely can. All right. So I guess it means that this square cannot be modified. Does it make any difference? The pattern is still here. This is still a pattern. Okay. So I'm not sure if it makes any difference. Why would you modify this variable in the code? Well, it's just like having final local variables in a method. I don't think it makes much difference. But this is really the gist. With this kind of code, you see that you get both the fact that you can keep your object model very simple because you are moving the behavior to the place where this behavior is needed. So you're not sharing the behavior with all your application anymore, which is a good thing. If you do not need this method because it now lives in a business module, if this business module is removed, the method that this business module was needing is also removed. So you have a process to remove code from your object model, like what I say. And if you add types to the sealed hierarchy, the compiler will warn you if you're using this switch that yes, there are things that you forgot to, there are cases that you forgot to handle in your switches, which is great. By the way, you can also write things like that. Because because now you can have constant patterns and you can handle null values cleanly in switch expressions. And if you want to have some kind of default stuff, You can also create an pattern with object, and it's warning me that this is not, yeah, that's a duplicate branch because it was there. Okay. You can also write this with any kind of class. You can also, if you want, you can also do this kind of thing. If you want this to handle this case only if so-called no, it's radius equals 0. I could say, oh, but this is 0 directly, and keep that for a more general pattern, for instance. By the way, this AND operator has a different status because this is still a pattern. Okay, so this Boolean operation to the right of the AND operator is called makes this pattern a guarded pattern. It's not the same AND as the one we had. So there are also little subtle things that are being added to this stuff. I think we are out of time, Nick. Is it?
Yeah, probably got a couple of minutes. I would say a few minutes.
Okay.
Start kind of.
Maybe if people have questions, maybe we can end up with a Q&A if you would like.
Yeah, we'll see if anyone drops any questions into the chat.
And this is not the chat. I'm watching the wrong stuff.
Yeah, there's nothing there at the moment.
Okay, that's fine. There are many more things. I'm really, if you're interested in that, there are many more things that are coming in this pattern matching stuff. The next thing that is coming is the possibility to deconstruct records. That is, I'm going to write some code that is not compiling, but really to write this kind of thing. For instance, you see, instead of writing this, which is nice, but which is still a little, yeah. How could I say? This call to square.edge is not very nice. That's the idea. The idea is to be the, okay, but I know that this square has been built on an edge. Okay, so I can directly use this edge there by deconstructing this record. This is not compiling because this is a Java 17, JDK 17 distribution with the preview features enabled. And this may come in Java 18 as a preview feature. But the idea is to say, instead of creating a variable of type square, I cannot directly, because record is built on components, and I know that, and the compiler know that. Okay, I can say that this square is built on an edge, and then my binding variable becomes the edge that is here. And by the way, if I do the same with rectangle, I could say that, oh, but this rectangle is a record built on an 8 and width. So I can also create 8 and width as binding variables and use them where it makes sense. This code is not compiling because it's not implemented yet, but this should come. I would say in a short amount of time.
Yeah, I mean, that's very nice. I suppose one of the things that will help us get access to that sooner, I don't know if it's been confirmed yet, but is bringing in the LTS kind of version in by a year. Because I suppose this might be like Java 18 or 19, but actually, usually we'd have to wait 3 years for this feature then, wouldn't we?
Yeah, absolutely. This should be able. It should be made available for Java 21, which is the next LTS.
So I've got a few questions. Yeah.
Popping up. Is that sealed classes? Is that just implemented in the compiler, or is there something new in JVM? That's an excellent question. Thank you for that. I forgot to mention it. If you try to cheat the system, right? If you try to creating a backdoor, creating your own implementation of shape by using some kind of reflection or some kind of agent or whatever, using bytecode manipulation, the JVM will catch you. So it's enforced both at compile time and at runtime by the JVM. So no, you can't create any kind of type that would implement shape directly at runtime in the JVM? The answer is yes, there is something new in the JVM about that. Is record support Jackson for JSON serialization mapper by default? You can certainly write your own Jackson code in a record. It's very easy to add because you can add any kind of instance method in the record and any kind of static factory method in a record. So you can definitely do that, absolutely. Doesn't that break the sense of encapsulation? It does. A record is not an encapsulated object anymore, because the state, the internal state, is exposed to the outside. Absolutely. Is it a good thing or not? I think that it's a good thing to be able to do that, but it does not change the concept of class. And if you want to create your own concept of class that enforces encapsulation, you can still do that. And I showed you with this range legacy class that even if you have a class that is fully encapsulated, and that you do not want to touch because of that, you can still use the possibility that records give you to close this security breach of serialization using this proxy serialization mechanism. I hope the answer is okay. If it's not, please ask more questions. Do you know if the new community site dev.java will take contribution for the community at some point? I noticed it was hosted on GitHub. It is indeed hosted on GitHub. There is a lot of content in it, and there are contributions from the community in certain portions of it. Absolutely. Since we opened the website, we got many requests from jugs and from people that are sending emails from us. Oh, could my jug be added to the list and this kind of thing? So if it's the case, yes, absolutely, definitely. As for the documentation, I would say that we are still in the process of moving older versions of the Java documentations to this new website and adding new kinds of documentation. If you have requests, by all means, you can post them. But I would say that we are not a team of 1,000 people to handle that, and we still have a lot to do, to say the least, to do that. But if you have ideas or anything, or if you point mistakes or things you think are not right, by all means, just tell us, and we'll gladly fix things. Yeah. Are there any plans for new content on Pluralsight? There is constantly new courses added to the Pluralsight library. So I would say yes. Now, if you're asking new content in the Java space, there was a new bunch of courses that have been added, I think, in September to help you pass the Java 11 certification. So I guess that as soon as the Java 17 certification will be published, new content will be released also in this field. Yeah, absolutely. And I think any plans to improve boot up time so that Java can be used more in serverless technologies? If boot up time is a concern for you, you need to watch what people are doing on the GraalVM space. And the answer is yes, there are plans, and there are some plans that have been published already. The first thing you can do is that you can create your own Java runtime environment distribution using the JDEP and the JDEPs tool, which will allow you to have a JDK that is just tailored for your application with only the modules you need. And for instance, if you are not doing any kind of database access, you can get rid of JDBC. If you are not doing any kind of graphical user interface, you can get rid of Swing. That's only two examples. The project Leiden is a project that has been launched to improve the boot time of the JVM. I don't think that it has released any element yet. I can't be absolutely sure, but yes, there's definitely efforts in that direction. But once again, I would encourage you to take a look at what the folks from the GraalVM team are doing to get elements on that. It's a Leiden, the project. I think there's a typo. If you're looking for project Leiden, maybe you will not find it because that's not exactly the name.
Cool.
Yeah, Leiden, as you wrote it, Nick. Absolutely.
Excellent. Yeah, that sounds great. Yeah, I mean, it's great to see how kind of the Java community is moving pretty quickly, really, compared to some of the times in the past. It felt like it was quite slow. So there's lots of new stuff coming all the time, which is cool.
I think we both remember this time, and I don't think we regret it.
No, well, not at all. Not at all. No. But yeah, no, that's great. So yeah, we are out of time. So thank you very much, José, for joining us. Really appreciate it. That's been really interesting. Hopefully, we've all kind of
thank you. Thank you very much, Nick, for great time spent with you and with your community.
Brilliant. Thanks, everyone. Cheers for joining.
Thanks, everyone. Have a good day. Bye.
See you again soon. Bye.